Hello everyone. So today we're going to go over section 7.1, graphing sine and cosine functions. We'll begin by graphing the sine function y equals sine theta using a table of values. So here we have theta equals 0, pi over 6, pi over 2, 5 pi over 6 pi, and so forth. And using special triangles and what we have seen in previous units, we can determine the values of sine theta. So that will be 0, 1 half, 1, 1 half, 0, negative 1 half, and then from there, negative 1, negative 1 half, and finally, at the end of the full rotation, 0 again. So notice that this grid has been customized with pi and 2 pi, and also negative pi and negative 2 pi as the values of theta. And we are graphing, once again, y equals to sine theta. That means every one of these spaces is pi over 6 wide. So we have when theta is equal to 0, we have 0. When theta is equal to pi over 6, we have 1 half. And then we have when theta is equal to pi over 2, 1. 5 pi over 6 back to 1 half. And when theta is equal to pi, we have 0. Then negative 1 half, negative 1, negative 1 half again, and 0. So now what we can do is connect these points with a smooth curve from 0 to 2 pi. Notice as well that if we were to move from negative 2 pi to 0, the same pattern would emerge since, for example, 0 and 2 pi are coterminal angles. Likewise, negative pi and pi are coterminal angles, and so forth. And then we can also draw that part of the graph. So what we'll notice is that this graph repeats itself every 2 pi. And this is called the period of the curve. So the period of y equals sine theta is 2 pi. Next, we can also check the zeros of this function. They will occur at negative 2 pi, negative pi, 0, pi, and 2 pi. So that would be, in other words, we can write this as 0 plus or minus pi, plus or minus 2 pi, and so forth. Alternatively, just n pi, where n is an integer. Okay, and that's, of course, the next part, the general solution. The domain of the function, theta, is an element of the real numbers. There is no restriction on theta. However, there is a restriction on the range, and that is between negative 1 and 1. Also of note are the center line of this function. In this case, y equals 0 is the center line. And the distance from the center line to the maximum or minimum of this graph is called the amplitude, and the amplitude in this case is 1. So we can mark that in as well. So when we're describing sine and cosine functions, some new terminology would be the center line, the amplitude, and the period. Notice as well that throughout the course of a single period of the sine function, at the beginning of the period, the value here is 0. Then halfway through the period, it is 0 again, and at the end, also 0. 1/4 of the way through the period, it reaches the maximum, and 3/4 of the way through, it reaches the minimum. So to summarize, start, we have 0. First quarter, maximum. Halfway point of the period, 0 again. 3/4 of the way through, we have the minimum. And finally, at the end, 0 again. So this is going to be true even if we change the period of this function. And that is for the sine function, in this case, y equals to sine theta. Next, let's look at the cosine function. Very similarly, we have, once again, a table of values here. So when theta is equal to 0, cosine theta is equal to 1. When theta is equal to pi over 3, then cosine theta is 1/2. And then we have 0, negative 1/2, negative 1, negative 1/2 again, 0. And if we continue scrolling down, 1/2, and then 1. So if we are to plot those points, we would have 1, 1/2, 0, negative 1/2, negative 1, negative 1/2, 0, 1/2, and finally 1 at the end of the period. So if we were to do the same thing again, connecting the points with a smooth curve, we have the cosine function like this. Sorry for that last part. That's better. Okay, so the same thing will also be true going from negative 2 pi to 0. So it will look like this. And again, connecting the points with a smooth curve. So just like the sine function, the cosine function also has a period of 2 pi. Again, if this is y equals to cosine theta, the period is again 2 pi, just like before. It also has the same center line and amplitude. So the center line is once again going to be y equals 0. And the amplitude is going to be 1. Let's go ahead and draw those in. Amplitude is equal to 1. And the midline or the center line, once again, y equals 0. And the shapes of the sine and cosine are the same, except for they are pi over 2 away from one another. So let's look at the zeros of this function. We actually have here, this is pi over 2, and then again at 3 pi over 2, negative pi over 2, and then negative 3 pi over 2. So we could generalize this once again, just like we did with the sine function. So we have plus minus pi over 2, plus minus 3 pi over 2. And of course, if we were to continue the graph, the next zeros we have will be at plus minus 5 pi over 2, and so forth. To generalize this, we will start with the first principal solution of pi over 2 and add integer multiples of pi. So compare this with the sine theta solutions of n pi. We can see that we added a pi over 2 here to shift the whole graph over by that amount. The domain of the function, once again, is theta is an element of the real numbers, and the range of the function is from -1 to +1, inclusive. Okay. So unlike the sine function, however, at the beginning of the function, the cosine function starts at the maximum. And then at the first quarter mark, it will be at 0. At the halfway point, we'll have the minimum. At the 3/4 mark, once again, another 0. And finally, at the end, it will be at the maximum. And this is true even if the period changes. It's still going to start at the maximum and end the maximum. Halfway point will be the minimum value, and the first and third quarter will be the zeros. Okay. So next, what we'll be looking at is how the transformations of functions can be applied to the trigonometric functions of sine and cosine. So in this graph, we're given y equals sine x, and we're going to use it to graph y equals 2 sine x and also y equals negative sine x. Okay, starting with y equals sine x, we know that the period is 2 pi, and we know that the amplitude is 1. Since the distance from the center line of y equals 0 to the maximum or minimum value is 1. Okay, so the original function that we're given here is y equals sine x. So next, we're going to graph y equals 2 sine x, and this 2 simply is a vertical stretch by a factor of 2. And what that does is that it does not change the period. The period is still 2 pi, but the amplitude will now be 2. So instead of y equals 1/2, for example, we'll have y equals 1. Instead of y equals to 1, we'll have y equals 2. And that applies to all of the points on the function. So if we were to draw a single period, this will be y equals to 2 sine x. Okay. And of course, next up we have also y equals negative 2 sine x, so that would be the vertical stretch by 2, and also a reflection about the x-axis. Now the period, of course, is still 2 pi. We did not do anything to change the period, but the amplitude is now still going to be 2. It's not going to be negative 2, since amplitudes are always positive. It's just a distance between the center line and the maximum or minimum value. Okay, so again, if we were to graph a single period of this graph, this is what it would look like. Okay, so next part, we are going to change the period. Let's look at example number 2. So in this case, we are given y equals to cosine x as our original graph here. And we are going to graph y equals to cosine 3x. So we know that this will be a horizontal stretch by a third. So for example, this point will not be moved. However, this point here used to be 3 spaces to the right of the axis, and now it will be a single space to the right. This point here used to be 6 spaces away. Now it will just be 2 spaces away because of the horizontal stretch by a third. This point used to be 9 spaces to the right. It will now only be 3 spaces to the right. And finally, the end of the period will simply be 4 spaces to the right of the axis. So we'll have a graph that looks kind of like this. So if we are to find the period of this graph, it would actually be 2 pi over 3. Which makes sense since the period of 2 pi was horizontally stretched by 1/3. Which leads to this relationship between period and the value b in our function. The period of the sine and cosine function is equal to 2 pi over b. This can be rearranged, of course, so that b is equal to 2 pi over the period. Okay, so next part, very similar. We're once again given the graph of y equals cosine x, and we're to graph y equals to cosine 1/2 x. So this is y equals to cosine x. Now this time around, of course, we have a horizontal stretch by 2. So the period is going to be 4 pi. We can also find that by the formula that we just saw. Period is equal to 2 pi over b. And in this case, b is 1/2. So we have 2 pi divided by 1/2, which of course is 4 pi. So this first point, again, will not be horizontally stretched. However, this point will now be 4 spaces to the right of the axis instead of 2 spaces. And this point here will be now 6 spaces to the right of the axis, and so forth. So that's the idea. So this point, for example, will be farther away. Oh, sorry, this point here moves to this location, right? And then the minimum will now be 12 spaces away. So it's very difficult to fit just one side of the graph onto here, so we're going to use both sides. It's going to look like this. So starting from negative 2 pi, we have the minimum value, and then it's slowly going to reach the maximum at x equals 0. And then the second half of the period will be from 0 to 2 pi, which makes sense because the period of the whole function is 4 pi. So we expect one cycle to span 4 pi horizontally. And there we have it. So of course, if the function was in degrees instead of radians, then we'll have 360 divided by the absolute value of b would be the period, instead of 2 pi divided by the absolute value of b. So we can look at some trigonometric functions here and just determine the amplitude and the period just by looking at them. So in this first case, the amplitude is going to be 4, since the a value is 4. And the period will be 2 pi over 2, which is going to be pi. Okay, next one. The amplitude in this case is going to be 3. And the period will be 2 pi divided by 1/5, which is 10 pi. Okay, next one, similar idea. Amplitude is going to be 2/3, and the period will be 2 pi over 2/3, which is actually 3 pi. Of course, if the b value itself contains pi, then it is possible to get, for example, in example D, an integer value for the period. So in this case, we have amplitude is equal to a quarter. Sorry about that. But the period is going to be 2 pi divided by pi. Recall we take the absolute value of b. So we actually have a period of 2. So we'll look at one more example where we combine a change in the amplitude and in the period. Okay. And so we can think about this as though they are just transformations for now. So we have a vertical stretch by 2, a reflection over the x-axis, and then a horizontal stretch by 1/2. So given those three transformations, let's look at these key points here where y is equal to 1 or 1/2 or 0. Also if they were negative, so something like this would be quite sufficient. So all the points where y is equal to 0, positive or negative 1/2, or positive or negative 1. And we'll see how every one of these points will transform into the new function. Okay, starting with this point here, it will not be horizontally stretched, of course, only vertically stretched and then reflected. So this point 0, 1 on the new function will be 0, -2. Okay, this next point here will be horizontally stretched by 1/2, so the new x coordinate is just going to be pi over 6 instead of pi over 3. It will be reflected, and then finally it will be vertically stretched by 2, so it's going to end up here. This next point will not be vertically stretched or reflected because the y value is 0, so it's just going to be horizontally stretched by 1/2. It's going to end up here. And then this point here will be horizontally stretched to here, and then reflected above the x-axis, and it's going to end up here at the end. Okay, so we almost have this whole part of the curve, and then from there we can use the symmetry to draw the rest of it. Actually, I think that's incorrect. Actually, I think it's supposed to be down here. Sorry about that. Okay, so that's last point. Instead of 6 spaces to the right of the axis, it's going to be 3 spaces to the right, and it's going to be reflected, so +1 and then multiplied by 2, so +2. So this part of the curve on the original function is now completed. It's going to look like this on the new function. Upside down, vertically stretched, and narrower, so that all makes sense. So from there, we can use the symmetry of the period to draw the rest of the graph. So here we have the next 4 points. Of course, we can also transform each point individually, but this is probably just faster. And then on the other side, same thing. We'll just mirror the period that we already drew to the negative side. And this will be y equals to -2 cosine 2x. Okay, next we're going to look at some properties of this graph. And that will conclude the section 7.1. All right. So first up is the period. The period was horizontally stretched by 1/2, so the period will just be pi instead of 2 pi. The midline, the graph did not move up or down, so the midline is still y equals 0. The amplitude is going to be 2, since there was a vertical stretch by a factor of 2. There's a single y-intercept, y equals -2. Okay, next up is the x-intercept, which is a little bit more complicated. This first x-intercept is 1/2 of pi over 2, so this is pi over 4. And notice between the first x-intercept and the next one, the horizontal distance is, let's see here, this distance right here. And that's actually pi over 2. And going in the other direction, this is also pi over 2. So every single one of the x-intercepts are pi over 2 apart, whereas regularly they will be pi apart. So what we have for the general solution of the x-intercept is x is equal to pi over 4, the principal solution, plus pi over 2, half the period, and then n, where n is an integer. The domain, x is an element of the real numbers. The maximum value is 2. The minimum value is -2. And the range, of course, is from -2 to +2. Okay, so that's it. We have looked at the sine and cosine functions, and we were also able to change their amplitude and period, and also reflect them vertically. And so that's it for today. So thank you for listening.